Hi, welcome. Thank you for coming in such a big number at our presentation. Today we are going to present you some of our journey in the cloud native universe, to say the least, and hope you like it.
Hello, my name is Mihai Mihalcea. I'm DevOps engineer and I'm working in this field from 2019. I graduated from the Military Technical Academy and I successfully obtained some certification relevant in this area.
Hi, I'm Octav. I'm 26 years old. I'm a DevOps engineer since 2020 at STS. I also graduated the same academy as my colleague, and I hold some relevant certification as CKA and CKS. Now that we introduce ourselves, let's talk about a little about STS, because not a lot of people, but you show me the otherwise, know about it. So STS stands for Special Telecommunication Service. It's a military institution from the National Security Defense System. His aim is to provide telecommunication and IT&C services to governmental authorities and other public institutions for the Romanian state. And also a very nice thing about it is that it's the sole administrator of the National Emergency System 112, the most important digital service from Romania. Now let's get to it and talk about the agenda. So today we're gonna delve into our STS platform, which are running on Kubernetes. We'll talk about some cluster design, then flow into our deep dive into our CI/CD pipelines. For the fourth topic, we have a central cluster. It's an in-house solution for one of our problems along the recent years. Then we specify some details about adoption and the challenges of Argo CD and Cilium. And at the end, we will conclude with some progress over time, some technology adopted along the way, and the challenges our team had.
Okay, so as my colleague said, the first topic is dedicated to the platforms running in Kubernetes in STS. This slide illustrates the most impactful platform developed by us for the general public use. Following the business, we can group this application in three main categories. First, application designed for helping Romanian citizens during the pandemic context. I mean the vaccination platforms and the green certificate. Application aimed to avoid the illegal wood transportation from our country. What is interesting about this platform is that anyone can track wood shipment and report the fraudulent one. And the last category, application created to facilitate the absorption of money from the European Union and the government. This application helps small and medium businesses to obtain grants for continue their growth. Now, let's see how Kubernetes cluster look at STS. Looking at the schema, we got the following. Firstly, we have our own data centers in several cities in Romania. Also, in the middle layer, we have VMware and OpenStack, on top of which we provision the node for Kubernetes cluster. Having our own infrastructure, we are not allowed to use public cloud like AWS or Azure, and we can't use features like self-managed Kubernetes cluster. For this reason, we need to handle operations like backup at CD, core DNS configuration, adding, upgrading, or removing nodes, and so on. From the point of view of installation, we have a dual approach using Terraform for provisioning our virtual machines with all the dependencies installed on them for Kubernetes cluster. After that, we use Ansible for subsequent configuration like cluster initialization, deploying CNI, adding labels to nodes. After the cluster is operational, we install a set of workloads like Prometheus, Nginx, and FluentBit for helping us in the management process. As you can see, Argo CD deployed these workloads from different Git repositories. Given the on-premise nature of our setup, we had to address the connectivity issue from two perspectives. First, serving data client application, and secondly, the communication between data plane and control plane. To overcome this, we use AJ proxy to establish a logical separation between external and internal traffic. You can see with red lines, traffic from clients reach AJ proxy and is redirected to the ingress of each data node. Additionally, the blue lines illustrate the communication between data plane and masters through kubeAPI API calls. So AJ proxy enable us to create a multi-master in the highly available architecture.
So now that we are familiar with the cluster design we got, let's talk about our CI/CD pipelines. First of all, a developer commits something on a code repository, and that triggers a Jenkins job, a creation of a Jenkins jobs, which run multiple operations right here. We'll talk about them later. So if everything goes smoothly, we'll have image container pushed to an artifact repository, and on the other side we have a set version. This means the Jenkins job will patch some YAML or file from our manifest repo, the blue one, to the designated version. Sometimes in our deployment flows, some manual intervention is needed from the operation team illustrated in the bottom left. And they also commit some changes on the manifest repository, the blue one. After that, forward, Argo will take care of everything. He will deploy everything from the designated repository into the cluster. And of course, those workloads will pull the images from the artifact repository mentioned earlier. Now let's focus a little of the Jenkins process. We use Jenkins file to construct the stages. Our most deployed workloads are written in Java, so we use Maven to build the code. Afterwards, we manage some code inspection with SonarQube. Then the Docker will build the image. After that, we use Trivy. Trivy is open source tool from Aqua Security, which will check the image from CV dictionary and will also generate a report. That report is also can be used in the Jenkins interface and is sent to Minio buckets for further possible investigation. If any of those jobs failed, we got a use case when an alert is sent to our Mattermost channel where the development team or the operation team will be notified.
We will continue now to present a concept which for us represents a solution for the problem that we encountered. Usually our application needs to exchange or validate information with another public entities. So our development team create a module to facilitate this exchange of information, acting as a proxy between us and other entities. But as time progresses, additional platforms emerge. Each of them requires similar proxies. So in that point, it was obvious to us that we were facing a new challenge. The process of the maintenance of these microservices require separate step of each individual cluster. So what was the solution? We consulted regarding this problem, and we decided to create a new management cluster to host all these proxy type microservices. Furthermore, in this cluster, we install all the common workloads used by all our application. My colleague will now continue to speak about it from another point of view.
So with all of that in mind, we thought why not to use that for Argo itself. So we patch a very muscle Argo CD instance on a cluster, and from that point we try to deploy every workload on the other cluster from that specific instance. We try everything being housed in one instance. We thought to try to improve our manifest and to standardize them in order to use the application sets for our Argo CD application later. So with that in mind, as I said earlier, our first challenge on how do we design our repository for for Argo CD to match our needs. So we try to categorize the repository in two ways. The common config is one which can be deployed on a large amount of class or multiple clusters, the same workloads, and the cluster-specific config, which will be unique to every cluster. So as the diagram shows, Argo will take the YAMLs from the two repositories and deploy into a cluster. I don't think it's very clear, but it's the red line, okay? So if you focus on the cluster, we zoom it, in the gray square where we have Fluent Bit and Longhorn, that corresponds to the common configs. And the ingress and the secret in the red square are from cluster-specific config. If we iterate this a lot, we'll have something like this. So we can deploy different subsets from common config in different clusters. And the question, how do we achieve this? We use a matrix generator in Argo CD application sets, but not whatever matrix generator, combination between a Git generator and the cluster generator. The Git generator gives us the following behavior. Every folder from that specific repository is a namespace, for example, Ser Manager, and if a file from a Ser Manager folder will be deployed in the specific object will be deployed in the Ser Manager namespace. And we also used in this scenario the cluster generator, which help us label the cluster we need to deploy on. We opt for a nomenclature of every cluster of having two labels, one for the application name, the platform name, and one for the environment. Those can be test, staging, or production, for example. And with all of that in mind and the scheme from a previous slide, we can actually have a very powerful configurable way to deploy the same workloads, but different subsets on different subsets of cluster, which help us a lot. Lately, for the cluster-specific configs, we opted for a simple approach, the list generators, but we wanted to have different sync behavior on each stage. And at that time, that wasn't possible with the standard template. We have to wait for the Argo CD page 2.10, where they allow us to template with fields that are not just strings, but as you can see in the example here, we have an if-like SQL, and that means that for this specific application set, it will generate 3 applications. For dev, staging, and production, and for dev, the autosync will be automated, and the staging and production will be manual for more control. Another problem we faced was deploying some CRDs. Even the CRDs were deployed correctly. They appear like autosync in the Argo CD graphic interface. So after some digging, we found out that specific CRD inherits some base structure from Kubernetes, and with this inheritance comes a specific way of converting data to YAML or JSON format. So because of this, those CRDs, when they are synced by Argo, they comport slightly different, generating this false positive, like in the problem section there. For the context, our CRD was tempo stack. And the fix was patching a config map in Argo CD, which basically means it tells Argo, okay, for this CRD, for these fields, this kind of fields, I want you to apply in this particular way. It's also a documented issue on the Argo CD online documentation.
Okay, so why Cilium? Until 2022, all our clusters use Flannel as CNI, but we aim to add an extra layer of security and a layer of isolation between our namespaces. So the next iteration was to introduce the network policy. Flannel was not designed to support this feature, so we continue our journey to find the best CNI for us with Calico. Calico enabled us to implement and adopt the network policy concept, but later we discovered that Cilium allow us to create more advanced network policy, including support for layer 7 base policy. So we started to migrate to Cilium. Another important propriety of Cilium is the observability, which allow us to better observe and understand our request and also to monitor the performance. We also replaced the traditional queue proxy based on IP tables with ABPF for its capability to process the network packets into the kernel. Another advantage was the open source community, which helped us to understand our problems, to provide answers to our question, and also for showing us that other people facing similar challenges like us. Even if it's a great tool, we had recently have a challenge. Last year in December, we decided to migrate all our development environment of all application in one cluster using Cilium CNI instead of Flannel. Our application use a lot of cron job for processing and moving data from one microservices to another. We sum up around 150 cron jobs. About 100 cron jobs was executed every minute. So in the middle of January, we saw that we cannot create any new resources, any new pod in the cluster. After some investigation, we see a relevant log, no Cilium identities left in the cluster. So we start to investigate this problem. We listed all the Cilium identities, and we saw that we reached the upper limit of Cilium identities. And the first iteration to resolve this problem was to force garbage collector to be executed more often. So we decreased the amount of time between API calls for deleting a used object, but this setting didn't work. And we also noticed that we have a lot of identities generated by pods, generated by cron jobs. So in this moment, we decided to decrease the number of successfully executed cron jobs from 3 to 1. But these settings work temporarily, because after a week, we encountered the same problem. So we informed Cilium to not create identities for the pods created by cron jobs. These settings seem to solve our problem, but another root case was the Cilium version in that cluster, because we installed in that cluster one older version of Cilium, because we also want to test the upgrade for the production workloads. The last topic focuses on illustrating our professional journey, the technology we adopted, and also the way we manage the problems that we encounter. So until 2019, our development teams struggle a lot to find a way to migrate from monolithic systems to system based on microservices. As a result, in 2019, the first application hosted in Docker container was released. Next year, in 2020, was the first time when an application was deployed in Kubernetes cluster. So our cloud native story began. During this period, we learned a lot of things, like making a highly available architecture using AJ proxy, object storage via MinIO, configuring a logging infrastructure through Elasticstack, and managing queues with Kafka. Also, we created a mass mailing system based on Postfix and SendGrid. Next year, in 2021, we realized that we need to find a way to provision Kubernetes cluster as quickly as possible in an automatic manner. So we started learning Ansible. Another automation tool was Cert Manager, which allow us to generate certificates for our domains. And also we started to use 3V for scanning files and other libraries in our pipelines.
And 2020 came, found us pretty well prepared, because we already have some experience with deploying and installing Kubernetes infrastructure. We adopted Keycloak for authorization authentication at the application level, and we also use it for some single sign-on integration with our intern tools. In the late 2021 already Kubernetes discontinued the Docker support, so we have to adopt accordingly. We started using CRI as the CRI, container runtime interface, and in that year also adopted Argo CD. Then 2023 came across, and a very important project knocked the door, the MySmith 2021, and we realized at that point that all the years past there seems invaluable as experience for that specific project. Also, we have our first migration of a project from a monolithic infrastructure to Kubernetes. In this case, it's Corona Forms. We changed again our CRI to Containerd. We also adopt Cilium that year, and speaking of that, I think that Cilium adoption was one of the best adoption we got overall as a tool, because the traction was pretty good. In a specific low amount of time, almost 90% of our cluster were running Cilium already. And another important topic was Terraform. Our platform teams adopted Terraform, slightly reduced the time for provisioning Kubernetes nodes for us. That really helped us. And now, in 2024, we presented CKD, and looking back of all those years, were quite a journey, to say the least. And I think that's it. Thank you. And you have a QR for feedback, for giving feedback.
Thank you.
Yeah, thank you. If you have questions, okay.
Who wants to go first?
Hi there.
Hi.
I'm Nistor from Oxygen Messaging. I'm curious, as long as it's not confidential information, are you running the 112 system also on Kubernetes?
It's in Kubernetes, but it's managed by another team, and wasn't developed from as the project we presented. It came on top of some other layers, so we don't have pretty good details about it, to be honest.
Okay. And the second one, could you give us, for the services that you're running on the K8s, could you give us an idea of the scale, of the size of the, again, if it's not confidential, number of nodes, number of requests per day, per second, tops, just out of curiosity?
We don't have a really large cluster. I think the maximum number of nodes is 30, but we have we really want to become more specialist in scaling cluster and using a lot of nodes.
The idea is we have like pretty medium cluster size, or from, as my colleague said, up to 30. And I think at the current we have like 8 or 9 platforms running.
Yes.
It's funny because in the early iteration of this presentation we got explicitly a slide with all the numbers, but we didn't memorize it, to be honest. So we can give you a specific on-point number.
My name is Sergey. Thank you very much for this incredible presentation, and respect for running this very important infrastructure. So my question is about licensing. I saw that you are using Minio, also Terraform, and the licensing about these products is tricky. I'm curious how you are addressing this kind of issues. Thank you.
Sorry, can you repeat that? How?
So it's about the licensing for products like Terraform or Minio or Elasticsearch. Is it okay to run it like for government?
There are free version of these technologies. We don't use the paid one.
Okay, thanks. But do you have a certain process or a team that helps you to select licensing, or tell you that it's okay to use it in your project or not, or it's on your shoulders?
We have a platform team, the virtualization team that help us to provision the Kubernetes nodes, but anything like cluster administration is on us.
No, it's like the question I think is more if it's a help, if someone is helping you to assess the licensing, the security of the product that you are using, or it's on your shoulders. I mean, you are analyzing the products, the third-party products that you are using.
Not quite. That task is from another department, from the STS, and they specific checks from security in different layers on the solution, the platform itself. Is not on us to be explicitly to respond to the question.
Okay, I think we can have 2 more questions.
Just another question to the previous one. Is your security team that approves these applications, are they good enough in understanding this, how these applications work? For example, I've seen many people still requesting screenshots as an evidence of, let's say, access level, but nowadays it's all configured in Git, let's say. Do they accept code in Git as an evidence?
So I'm so sorry, I didn't quite follow the question, to be honest. Can you rephrase a little?
Okay. I've understood that you have a separate security team.
Yes.
That approves your applications which you use on your platform, right? Okay. Do they have professional knowledge of these applications, how they work? Or you have to explain them?
I think the security team can help us, and I think we have professional team for that. And I think, yes, they can help us.
One more question.
Here.
Yeah, so I'm just wondering about that Argo CD instance you have right there. What does it look like? What's the load? How many applications does it manage?
The current like 100 application grouped in like, I don't know, 20 application sets, something like that.
Okay, and what's the resource allocation like? And do you notice any hiccups?
I think we mostly, from the resources point of view, we just install the high availability installation from Argo CD, and we tune it with some configs, some like for that specific CRD or another topic. We added some mini tunings for our use cases, but so far we didn't have so many problems with the syncing speed or something like that. The graphical interface was pretty okay over the last period. No problem.